Hey friends, welcome back to my YouTube channel Reasons and Logics. Here I'm back with lecture number 4 on electric charges and field, and the topics which I would be covering today are electric dipole, dipole moment, dipole field, electric field due to dipole at axial point, electric field due to dipole at equatorial point. Okay, so let's start. Okay, so let's start with the first topic, that is electric dipole. Fine. So, electric dipole is nothing but a pair of equal and opposite charges separated by a small distance. Fine. So this system is, say these are two equal and opposite charges and they are separated by a distance 2a, then this system is called the electric dipole. Fine. Next we need to know what do we mean by dipole moment and how can we calculate it. So dipole moment is something which tells us about strength of the dipole. Fine. And how can we calculate the dipole moment? We can calculate dipole moment by the formula given as dipole moment is equal to either charge multiplied by vector drawn from negative to positive direction. Fine. So this is how we can calculate the dipole moment. So electric dipole is just a system. Now the measuring quantity is the dipole moment. Like what is the nature of dipole, what is the strength of the dipole, all these kinds of things we can get to know from the quantity which is the dipole moment. Fine. And it is equal to either charge. Either charge means since we have two equal and opposite charges, so one of the two charges either plus q or minus q. Say if we are taking plus q, then q multiplied by the vector drawn from negative to positive direction, that is the 2a vector. Fine. One thing more, this line which joins the two equal and opposite charges is known as the dipole axis. Fine. So till now we have studied about three terms. One is the electric dipole, second is the dipole moment, and third is the dipole axis. This system is known as electric dipole, and the quantity which tells us about the nature of dipole, strength of dipole, that is known as the dipole moment, and it is calculated by the formula Q into 2A, and dipole moment is represented as P vector. Obviously it is a vector quantity since here we have a vector quantity. And third term was the dipole axis, that is just the line joining the two charges. Fine. Now, what are the SI units of dipole moment? So, from this formula, we can very easily find that SI unit of charge is coulomb, and since it is a distance, so SI unit of distance is meter, hence SI unit of dipole moment is coulomb meter. Fine? Okay. Now, next is ideal or point dipole. Fine. So this is just a definition that you can be asked that what do we mean by ideal or point dipole. So we can define ideal or point dipole with the help of certain conditions which could be applied on the charges and the vector. Fine. Now, if our charge approaches to infinity and distance between the two charges approaches to 0 in such a way that our dipole moment, which is q into 2a, remains finite because this is approaching to infinity and simultaneously it is approaching to 0, then this kind of situation or this kind of electric dipole is known as ideal or point dipole. Fine. For ideal and point dipole, you just have to remember this condition. Or if in a question, instead of the values we are given that we are considering ideal or point dipole, then you people should remember that these are the conditions which we have to apply for that. Fine. Next very important concept is the dipole field. What do we mean by a dipole field? So this is just the electric field generated by the dipole is called the dipole field. Fine. Now, how can we calculate it? We can calculate dipole field by using the formula for electric field. Number 2, using the superposition principle. Fine. Now see, we have this kind of situation, that is minus q plus q, and this is the distance between these two charges. Now very clearly, if we are asked to find the electric field at any point, say P, due to this system, then how can we find that out? As we have already studied, we can find it out by simply applying the electric field formula, that is the electric field produced due to minus q, and then electric field produced due to plus q, and eventually we'll add them using the vector law of addition, and finally we'll find the resultant electric field at point P. Fine. So that is how we can find the dipole field. Now see, since we have two equal and opposite charges present here, so one can say that electric field due to this system should be 0, because we have two equal and opposite charges, that is one is plus q, one is minus q. So the field produced by plus q charge should cancel the field due to minus q charge. Fine. So that is, we should have the dipole field is equal to 0. But this is not the case. Let us see how. Okay, so let us examine that why electric field due to dipole is not 0, or in which case we can have it equal to 0. Suppose this is minus q, this is plus q, and this is the distance between these two charges, and we have to find electric field at point, say, P. Fine. So this is 2a. Let this distance be r, and now we have to find the electric field, and let position vector be represented by say P cap. Fine. So now electric field due to minus q will be minus q, this k is 1 upon 4 pi epsilon naught, and this distance is 2a plus r whole square into p cap. And what will be the direction? Since always we assume a positive test charge at p position, so they will attract each other, that is, direction will be towards left in this case. Fine. And electric field due to plus q charge will be 1 upon 4 pi epsilon naught q upon, here distance is just r square into p cap, and this is towards right. Fine. So now when we will add them using the laws of vector addition, see, they will not cancel out each other because the distance involved in denominator is different. It's not just about the charges, it's also about the distance involved in these cases. Now assume that if we have to find the electric field at a point P, which is at a very large distance, that means if this is the distance r, then in this case we have r is very, very greater than 2a. Fine. So that means 2a can be neglected with respect. So that means in this case 2a can be neglected. Fine, obviously because r is very, very greater than 2a, so 2a is being very small, we can take it approaching to 0. That means we can neglect 2a. So then this electric field becomes 1 upon 4 pi epsilon naught minus q upon r square into p cap. Fine. Now when we will add these two electric fields, then they will cancel each other. Fine. So in this case, the electric field due to dipole will be equal to 0. Fine. What is the condition? R is very, very greater than 2a. Otherwise, when we are calculating at the smaller distances, electric field due to dipole is not 0, but for very larger distances, we can have electric field equal to 0. Fine. Next, we are going to study about electric field at axial point due to dipole. Okay, so now this is the situation which we have. We have minus q charge plus q charge separated by a distance 2a, and we have to find electric field at point P. Fine, which is at a distance r from the midpoint of this dipole. Fine. Okay, so like we did in our last case, we can write the electric field due to minus q charge as 1 upon 4 pi epsilon naught minus q upon, what will be the distance involved? This is AP, that is AP square. Fine, and let the position vector be represented as p cap due to a dipole, because we represent dipole moment by p, that's why I have chosen p cap as the position vector. Fine. Now what will be AP? AP is equal to AO plus OP. Fine. That is AO plus OP will give us AP. What is AO? Since O is the midpoint, so AO is A plus OP is R. Fine. So electric field due to minus Q charge will be equal to 1 upon 4 pi epsilon naught minus Q upon A plus R whole square into P cap, and what will be the direction? Direction will be towards left, because here we suppose a positive test charge, so they'll undergo attraction, so this test charge will get attracted towards minus Q charge and hence direction will be towards left. Okay, next is the electric field due to plus Q charge, because obviously we have to find electric fields due to this, and then we'll add them. Fine. So this is 1 upon 4 pi epsilon naught plus Q upon BP square into P cap. Fine. And direction will be towards right, because they will repel you. This charge will move towards this direction. So this is the direction of electric field due to plus Q, and this will be the direction of electric field due to minus Q. Fine. Now what is BP? BP will be equal to OP minus OB, that is R minus A. Fine. So electric field becomes 1 upon 4 pi epsilon naught plus Q upon R minus A whole square into P cap. Fine. Okay, so this is what we have got till now. Now we will add to find the electric field at the axial position. Fine, that is the total electric field at point P. That will be equal to electric field due to minus Q plus electric field due to plus Q. Fine, that is nothing but equal to Q upon 4 pi epsilon naught is common, and 1 upon I am writing it at the first place because then we will write this with the negative sign. So 1 upon R minus A whole square minus 1 upon R plus A whole square into P cap. Fine. And solve, we get E axial equal to Q upon 4 pi epsilon naught 4 AR upon R square minus A square whole square into P cap. Fine. Now we know that Q into 2A is nothing but the dipole moment. So we can write it as, since we are dealing with the magnitude only, so this becomes 2 into P into R. Like this can be written as 2A multiplied by 2. Now 2A into Q will give us P. This 2 and this R is as such upon 4 pi epsilon naught into R square minus A square whole square into P cap. Now direction of dipole, as I explained earlier, is always from negative to positive, that is towards right. So this total direction of electric field will be towards right. Fine. Now what if R is very greater than A? Then we can neglect this A, and electric field due to axial becomes 2PR upon 4 pi epsilon naught into R square whole square into P cap. That is nothing but 2P upon 4 pi epsilon naught R cube into P cap. Fine. So this is the electric field at the axial position for this special case, which is R is very greater than A. That is, if we have to find the electric field at a very large distance. Fine. And direction of the electric field will be along the direction of the dipole moment, that is towards right. Okay. Next we are going to study about electric field at equatorial point. For that, firstly we'll have to draw the diagram. So let us understand with the help of diagram first. So this is the dipole, that is minus q placed at A plus q placed at B, separated by the distance 2a. Let O be the midpoint of this dipole and P is the point where we have to find the electric field. Now let OP is equal to R, and since O is the midpoint, then AO will be equal to A, and similarly OB will also be equal to A. Fine. Next, using the Pythagoras theorem, this distance will be equal to R square root of R square plus A square. Similarly, this distance will be equal to R square plus of A square, and let this angle be theta. Fine. Now let us draw the electric field. To find the electric field, we always assume a positive test charge placed at point P. So, if here we have suppose some unit positive test charge, then this positive and this positive charge will repel each other, and this will be the direction of electric field, that is E plus Q. Fine. Let me write it. That is E plus Q. Similarly, this charge and this charge will attract each other, and this will be the direction of E minus Q. Fine. Now we will divide this electric field into its components, that is due to plus Q, one component will be along this direction and the other component will be along this direction. Fine. Since this angle is theta, since corresponding angles are equal, so this angle will also be theta. Fine. Now this component will be E plus Q cos theta, and this component will be E plus Q sin theta. Fine. Similarly, for E minus Q, one component will be along this direction only and other one will be along this direction. That is, this will be E minus Q sin theta and this will be E minus Q cos theta. Fine. So this is all about the electric field and its components, which we are going to deal in the case of finding electric field at the equatorial point. Now we'll start with our mathematical part and we'll see which of the components cancel each other and which gets added, because in this we are not going to simply add electric field as we did in the axial case. Okay, so let's start with that. Now I have drawn the diagram on right hand side, and now let's proceed with the mathematical part. Firstly, we'll write the magnitude of the electric field. See, what will be the magnitude of electric field due to plus Q charge? It will be equal to Q upon 4 pi epsilon naught R square plus A square, because square root and square will get cancelled. Fine. So this is the electric field due to plus Q charge. Similarly, for what will be the magnitude of electric field due to minus Q charge? That will also be equal to Q upon 4 pi epsilon naught R square plus A square. Why? Because we are dealing only with the magnitude of charge and not the sign of the charges. Fine. So this is the magnitudes of the electric field in both cases. So very clearly, magnitude of electric field due to plus Q charge is equal to magnitude of electric field due to minus q charge. Now E plus q vector is made up of magnitude of this cos theta plus magnitude sin theta. Fine. Similarly, E minus q is made up of E minus q cos theta plus E minus q sin theta. Fine. Now see from the diagram. Cos theta component of both the electric fields is along the same direction. So they will simply add when we will find the equatorial electric field. But what about the sin theta component? Now this sin theta is in the opposite direction for both the cases. So this portion will get cancelled out because magnitude is equal and they are pointing towards the opposite direction. So these both will get cancelled and the final equatorial electric field will consist only of theta components. Fine. So the magnitude of the equatorial electric field will be equal to E plus q cos theta plus E minus q cos of theta. Fine. Now we'll put these values here and we'll find the magnitude of equatorial electric field. So now equatorial electric field, magnitude of equatorial electric field will become magnitude of E plus q, that is this one, into cos theta plus magnitude of electric field due to minus q into cos theta. Fine. And this is nothing but 2q cos theta upon 4 pi epsilon naught r square plus a square. Fine. Now see what is the value of cos theta from this equation. Cos theta is equal to a upon under root of r square plus a square. So putting this value back here, we get E equatorial is equal to 2qa upon 4 pi epsilon naught r square plus a square raised to power 3 by 2. Fine. Now what is the value of q into 2a? That is the p. So this is magnitude of the dipole moment upon 4 pi epsilon naught r square plus a square raised to power 3 by 2. And in the vector form, we'll just multiply it with the unit vector, and E equatorial in the vector form will be equal to either p vector or magnitude of p into p unit vector upon 4 pi epsilon naught r square plus a square raised to power 3 by 2. Fine. So this is the formula for the electric field if our point is located at the equatorial position. Okay. Now see, this is what we have got for the equatorial position, that is 1 upon 4 pi epsilon naught p upon r square plus a square raised to power 3 by 2 into p cap. Fine. Now suppose if again we have r is very greater than a, or we call it as the short dipole. Fine. If a is very small, we call it as the short dipole. Okay, so then E equatorial becomes 1 upon 4 pi epsilon naught, we'll neglect a, and this will become r cube into p cap. If you remember, the electric field due to axial short dipole case was 1 upon 4 pi epsilon naught 2p upon r cube into p cap. Putting the value of this whole thing from this equation into this equation, we get E axial is equal to 2 times the E equatorial. Fine, for the case of short dipole. This is the condition. For the case of short dipole, E axial is equal to 2 times the E equatorial. So friends, this was all about lecture number 4 on electric charges and field. I'll see you all soon in my next video. Till then, take care. Bye-bye. If you like this video, do like it, share it, and don't forget to subscribe my YouTube channel. You can also follow me on Instagram. My Instagram ID is mentioned on the screens and link will be mentioned in the description box. Thank you.